First, we will see the basic introduction and the definition of machine learning and what are the basic steps involved in to develop a machine learning model. And then we will little bit talk about what topics that comes under the advanced machine learning, or that we can call as a deep learning also. And at the last, I will try to cover the recent trends inside the mechanical engineering, what nowadays people are following, that application of machine learning in mechanical engineering. We all know that the present era is the era of the artificial intelligence and machine learning. So basically, if we will talk the few famous definition of the machine learning, so first definition we can simply read as like machine learning is the science of getting computers to act without being explicitly programmed. Okay, so this definition says that we are trying to make the computer intelligent, that without means mentioning a type of rule, or a type of set of some program. And if our computer is becoming so much intelligent that he can take the decision by its own without the need of any human, so that we can call as a type of machine learning. And one more definition is also famous. Say a computer program is said to learn from experience E with respect to some classification class of task T and performance measure P. If its performance at task T as measured by P improves with experience E. So one performance measure is required, that how well your computer is performing with respect to machine learning. Okay, task we have to define which particular task we have to perform. Okay, and experience means experience is same as like a general human being. If you are doing the same thing repeatedly, so he will become an expert of that particular task. Okay, so if you are giving same data or same instruction multiple times for the program, so are that program is able to learn from that continuous learning or not? So it is type of means a continuous process in which the program is learned from the same type of task that we are repeating over that program. Okay, so in general, if we can say, like machine learning, a type of a model or type of thing in which we are providing the data available to us. Okay, some predefined algorithms are there that will learn from that particular data, and at the end we will get a model of machine learning, which is ready to take the new data and predict the new value, or do the classification. Machine learning is a subset of the artificial intelligence field. Artificial intelligence field is very vast, that is covering the data science, okay, then your evolutionary computation, soft computing, all comes under the artificial intelligence. So machine learning is also a, we can say, sub part of the artificial intelligence. Means in past, the traditional AI techniques, what they are taking the data, as well as we need to define the logic also. So it is the, you can say, past in which we need to also define some rule, okay, rule over the data, and according to that we are getting the outputs. Okay, so in this data we are providing, as well as logic is also written by the human expert. Okay, so these are the, you can say, hard-coded set of steps or the scenarios, okay, which will not able to update themselves, and generally it is known as the rule-based expert system. And here, no generalization means handling special cases difficult, means for whatever type of data that rules are written, only over that data these rules are valid. So no generalization is there. While in the case of machine learning, what we have to provide as input, data we have to provide, okay, and output means the actual data we have to provide, actual output we have to provide. And whatever are the algorithm or mechanism of machine learning is there, they will give the logic, means they will automatically develop a rules, which are also a dynamic nature, means according to the data, their rules may be vary within the model. Okay, so data and output we are providing and by matching the input data and output, our machine learning algorithm will develop or learn a model. So we can say that we are getting the logic from which this data is mapped to the output, or input is mapped to the output. Now it is, you can say, a type of challenge, or means it requires some knowledge, that over which particular problem we can apply the machine learning algorithms, okay, or what thing we can easily model. Okay, so see, generally your machine learning is basically applied on these two types of problem, which are task programmer can't describe. Means a type of task which we are not, means as a human we are not able to solve, or predict the relation between the input and output variables. So like your handwriting is a type of that problem. Okay, see, as said, no specific mechanism is there, everybody is having own style of writing. Okay, so there is, we are not able to make some rule, that a specific person will write in a specific manner. So it is a kind of thing that we can not define any mathematical formulation for handwriting recognition. So that task can be easily solved by the machine learning algorithm. Simply, cognitive reasoning means we know the intelligence level, or the knowledge level of all the persons are different, and how they are making the decision in daily life is also different, based on the circumstances they are taking the decision. So again, it is a type of problem that we cannot define, in the terms of mathematics, or some logic. So that thing also we have to learn. And in general also, say like we are the human, so if we are doing any type of task for the first time, so we are not aware of the process, or the steps involved, but if the same task we are repeating for the multiple times, so we get experience, and we will become expert in that particular stuff. Okay, so this type of problem, and one more type of problem are there in which multi-dimensional situation is there. Okay, and we also need to apply some numerical reasoning. So like the problem of your weather forecasting, healthcare outcomes, network institution, and movie recommendation system. So the common thing in all the second class of problem is that they are having the multiple attribute associated to them. And like for weather casting, so many variables are there, multiple attributes are there. On the basis of that, we have to take the decision. In similar way, in healthcare also, multiple attributes are there, like the condition of patient, and means from the same patient we are recording the multiple attributes, like we are monitoring the BP, heart rate, sugar level, etc. So based on, means multiple variables are there, based on which we have to take the decision. Okay, so on these two type of problem we can apply the machine learning, because they are not easily solvable with the AI methods, or the traditional rule based method. Means previously people are working, but nowadays when machine learning is becoming very familiar to all, so generally people are applying only machine learning algorithm to solve these kind of problems. So machine learning we can simply classify into two type of categories: supervised and unsupervised. So in case of supervised learning, what happens whenever we are giving the data to the model, or to the algorithm, the actual output is known to us, and that we are also providing to the algorithm. So say if I will take a simple notation, say X is our data, okay, and Y is the output. Okay, so this thing generally we are giving as the input X, and this is your output Y. Okay, and we are not able to identify or configure the relation between X and Y. Okay, this we are means in general case we are not able to model. So these two things we are giving as the input to the our machine learning model. So information we are providing, as well as answers also we are providing to the machine learning model. So this model will train on that data, so it will trying to find out the relation between the input and output variable. Okay, so this is a simple problem that we can call is like this: y is equal to f of x. So x we are giving as the input, means input data we are giving, and that will give me the output. Okay, so this thing we have to do, and generally in the terminology of machine learning, when we are making the prediction, so again f is there, means function is there, we are giving the input, and we will get the output in the terms of prediction. Okay, so if the difference of this predicted value and the real y is almost equal, so then we can say our model is perfectly trained. Okay, so these basic things we will further discuss in the lecture. But see, supervised is simply we can classify where x and y both are available, means input and output both are available. And in case of unsupervised learning, where we are having only x, okay, there is no y and no class or no prediction is there, and simply this x we have to we can say the simplest example is the clustering method. Okay, see, multiple instances or multiple samples of x are available, and generally we have to arrange in two category or arrange in two class. So type of clustering problem we have to solve, where no actual output is given. Okay, so here are the some examples in the name of supervised and unsupervised learning. Inside a supervised learning, regression and classification we have to perform. So regression simply means real value or the continuous values we are predicting. So linear regression, your ordinary least square regression, local regression, and neural network. These are the famous and the basic techniques of regression. Similarly, for the classification, when we want to predict the input into the different categories or into different classes, so we can take the help of decision tree algorithm, k nearest neighbor, support vector machine, logistic regression, naive Bayes, and random forest algorithm. So these are the algorithm used for the classification purpose. And in case of unsupervised learning, the main category is clustering, and along with the clustering we can also do the dimension reduction. So the famous technique for clustering is k-means clustering and hierarchical clustering. And the dimension reduction, the two most famous techniques are your principal component analysis and linear discriminant analysis. Okay, and generally these dimension reduction techniques are also useful to extract the feature from the data. Okay, because generally say multiple recordings are there, or your attributed dimension is so much high, so anyhow we have to reduce the dimension, so our machine learning algorithm will take less time to execute, or we are extracting some meaningful information from the raw data. The present scenario, we are seeing that the entire world is filled with the data, means with the beginning of the digital era, lots of sensors and their recording methods are available. So we are having the huge amount of signals, images, multidimensional data, and all we are simply using for the information extraction. So previously what happened, when data is also less and the computational intelligence is not you can say level of the present day, so at that time rule based approaches are used. So these rule based approaches are nothing, is simple rules, or you can say a thresholding values are there for different data, so by which we can simply make a simple type of decisions. Okay, that is the past case when we are not having the machine learning or the you can say deep learning kind of things. Okay, so simply we are defining the rules, and based on that rule we are simply checking the input value, and accordingly we are taking the decision. Okay, but at present model will be learned from the data and has the flexibility to change with data. Okay, so nowadays when machine learning algorithms are used, so we can simply train our model, and these models are also flexible that according to the change in data they can adapt itself. So many application domains are there, like signal classification, image classification, and your face recognition, speech recognition. Okay, so these are some common application. And in the network, if we can see the your fraud identification, or for security purpose, we can also use the machine learning. What are the basic steps involved in the machine learning process? And that the base we have to build with a simple, you can say, definition: the using data to answer the questions. Okay, so here you can see two parts is there in definition. We have to use the data, and we have to answer some question. Like the question is simple as that, see, whatever input data we are giving, so that particular data belongs to which particular class. So using data means it is a training phase. Okay, whatever data is available with us, that we are using for the training of our model. Okay, and answering question means it is a testing or the prediction phase. And once we have defined a model or trained a model over the existing data, and so either new data we can apply to answer the new questions. And so training phase and testing phase. Okay, now the workflow of ML is like this. Initially we have data. Okay, and this data we are using for the training purpose, through which we will get the model, and we will apply the new data or the test set data over that model to answer the new questions. So this is very basic flow. Data we have to take, we have to train the model, and once our model is trained, we can apply the new data to answer the questions according to the new data. These are the 7 basic steps that we have to learn, whenever we are applying the machine learning to any field. It may be the mechanical engineering field, or the computer science field, or the electronics, or any field. And so these basic steps remain the same. So first one is the data collection.